Sum and difference identities. They're on the bottom of page 579, if you want to look at them. I am going to write them up on the board, not on the smart board, so they will stay there while we work problems. Okay? So for those at home, you need to have the identities written on your paper. Well, you guys are writing them down, aren't you? Yes? No?
What?
Excuse me. These identities use more than one letter, so you have to be careful about changing letters. They are on your pink sheets. Are they on the top of the second page? Yeah. Is that where they are? All right. Sum and difference. The first one says sine of x plus y. You can use any letters. I like x plus y because that's how I learned them. Is sine x cosine y plus cosine x sine y. It said sum and difference, so if I do a plus, shouldn't I do a minus?
Yeah.
So the sine of x minus y is sine x cosine y minus cosine x sine y. What's the difference in those two?
One's the sum, one's the difference.
No, I mean the formula. If you notice, they're just alike, except the plus had a plus, the minus had a minus.
One's the sum.
Learn one, you learn them both, right? Okay. What if I have cosine sum? Cosine of x plus y is equal to cosine x cosine y minus sine x sine y. Now let's do a difference. Cosine of x minus y. It is cosine x cosine y plus sine x sine y. So cosine is just the opposite. You see that? What is left is tangent. Tangent's not as pretty. The tangent of x plus y is equal to tan x plus ny over 1 minus tan x tan y. And the last one is tan x minus y, which I'm just going to switch the x at my place. Tan x minus tan y over 1 plus tan x. Alright. Are we good with those? They all have them in front of us? Yep. Because I would like to work some problems with them, okay? Okay. Hard one or easy one to start?
Hard one.
Easy to start.
Hard one.
Easy to start. I'm going to give you a hard one here. So you might want to start with easy.
Yeah.
Hey,
Don't
I'd like
let's
to
see-
learn
I
it
wanna
first.
see where we-
I like to learn first.
This is what I want. I want to find the cosine of 165 degrees. Now, we're finding exact values, which means we have no decimals. So what I have to do is I have to think of all the angles that I know to deal with. All right? Well, first of all, I know all the ones on axis, don't I? 0, 90, 180, right?
Would you have to probably the record label? Is that important?
You will have to do it, yes. That's what we're going to go from. So we know, I know 0, 90, 180, 270, and 360, right? I know all those angles. Can I find the exact value of a 30-degree angle? No, that's in radians. That is not a trig function. But can I find the cosine of 30 degrees?
Yeah.
Don't I have a 30-60 right triangle that I deal with?
Mm-hmm.
So I can use 30 degrees in any quadrant. Yes?
Yes.
So 30 degrees in quadrant 2 would be what? I think it'd be 150 degrees.
Oh, yes.
Wouldn't it?
Yeah.
What about in quadrant 3? 210 degrees. What about in quadrant 4? Do you all agree? Could I also find the exact value of a 60-degree angle? Right?
Yeah.
Okay. So what is 60 degrees in quadrant 2? 120 degrees? What would it be in quadrant 3? 240 degrees? And quadrant 4? 300 degrees. There's one other angle that I can find the exact value of. 45 degrees.
Oh, yeah.
Right? So 45 degrees. What is 45 degrees in quadrant 2?
Yes.
Okay.
Wait, what did you say it was again?
135. What about quadrant 3? 225 degrees. And quadrant 4. Okay?
So then that's like, so what does that have to do with that?
These are the angles that I can find the exact value for. Since I'm doing sum or difference, I have to find 2 of these angles that either add or subtract to my 165 degrees. What?
I'm just figuring it out.
2 angles that add or subtract to 165 degrees. 135 and 30. Does that add up? Are those on my list? Would 120 and 45 work?
225 minus 60.
So there's a lot of possibilities. And I really don't care which one you use. You will get the same answer. So, what would you like to use?
I would like to use 225 and 50.
You want to use cosine of 225 degrees minus 60 degrees.
Yup.
Is that right?
All agree with me?
No.
Okay.
All right.
Very happy.
So now, since I'm finding cosine, I go back to my formula. This is a minus, so I use cosine x minus y. Right? What is x? 225. What is y?
60. Negative 60.
No.
No, yeah, just 60.
60.
We just plug in for
No, because it's exact. So this is cosine 225 cosine 60 minus sine 225 sine 60. You understand what I've done?
Yeah. Here's what you've done.
Now's where the thinking comes in.
Oh.
What is the cosine of 225 degrees? What quadrant is it in? Three. Is it going to be positive or negative? Hold on. Is it positive or negative? You're ahead of me. You're ahead of me. Cosine of 225 in quadrant 3. In quadrant 3, is cosine positive or negative? I think it's negative.
All
yeah.
Don't we do all students take classes?
It's negative. Not all students classes take.
Negative.
It is not all students classes take. It is all students take classes.
So, you agree, my answer is going to be negative.
Yes.
If it's 225 degrees, we know the reference angle is 45.
Yeah.
And I am hoping that you all know what the cosine of 45 degrees is. What is it?
I want to give this answer in radians.
No, I don't want radians.
I don't know how to give.
Yeah.
No, I don't know.
I don't know what the.
Sarah got it. Sarah got it.
Okay, it's right here, isn't it?
Oh, it's the one
This is 45 degrees.
It's the one the one. So it's the 2 over.
Negative radical 2 over
Yes.
2.
Sarah got it.
There's so many.
Good job, Sarah.
There's so many different like concepts and like I think reference I think like cosine and I just assume radians. It was radians. And I'm like, oh wait, we
Everybody agree with that?
What agree with that?
Everybody can understand where I got that number?
Yes.
And so you plug that in. Oh,
Just for that. Now, what's the cosine of 60? Is it 60 in quadrant 1?
that is.
This is 60? What is the
Radical
cosine of
3
this?
over 2.
Yes. Radical 3 over 2?
Let's go, Sarah.
I knew it.
Radical 3 over 2. Y'all with me?
Yes.
Yeah.
Remember, this is an easy one, Sam.
Yeah, I'm getting.
Oh wait, no, hold up. Is it 1 over? No, wait, is it 1 over 2?
What?
No.
Is it?
Wait.
I don't know.
No,
Guys, isn't this radical 3 and this 2?
Yeah.
This 2, this 1.
Wait.
yes,
No.
it's 1 over 2. If you look at the cosine, I'm an idiot.
Yeah.
I was thinking sine. I'll admit, it wasn't like I thought that was cosine.
Okay,
I was
sometimes we have to just stop a minute and without any noise coming out of our mouth.
Oh, so sorry.
Come on, gentlemen. No,
Yeah.
I was thinking the same thing.
Sine of 225. We're still in quadrant 3, aren't we? So sine is positive or negative?
It's negative.
Negative.
Is it the same?
Yeah.
It's the same thing as what?
As cosine is 2
Okay, so you're saying this is negative radical 2 over 2?
Uh-huh.
Yes.
I'm thinking that's correct.
That is
You were
correct.
right down the
it's
board, so I feel like I'm moving in the right direction.
Now, what is the sign of 60? We have my title
It's
right
radical 3
here.
over 2. Three over 2.
Radical 3 over 2.
Oh, we have to multiply and subtract.
Right?
Oh.
Yeah, yeah.
Okay. Is this negative radical 2 over 4?
Yes.
Sure.
Okay, you learned how to multiply fractions a
Oh,
long
I
time
thought, I
ago.
thought.
Oh,
you
yeah,
were
yeah.
at the right
Yeah.
one.
No,
Yes, it is.
just this one.
Yes.
Yeah, yes.
Now, is this minus going to become a plus?
Yeah.
That it will.
Yeah.
Kind of.
When I multiply radicals, if both numbers are into the radical, I just multiply. So isn't this radical 6 over 4?
Yes.
No, but they have the same common denominator.
How nice.
Whoa.
So it's
Negative radical 2 plus radical 6 all over 4. And that is my answer.
Wow.
That wasn't
that was kind of nice. I kind of appreciate it.
Oh, wait, that was an easy one.
I was trying to say, it wasn't that hard. What happened is we got wrapped up in, oh my gosh, I haven't thought about this in too long.
Yeah.
Am I right?
Yeah.
Because once we did it, you were like, oh yeah, I knew that. Oh yeah, I knew that.
Give it a little. Sure. Okay. Let's do a hard one.
Okay, we're still harder, which means we have to think, right?
Oh, yeah.
Oh, is there a harder
My
one?
special.
Your specialty,
Yeah.
good.
All right.
Right.
How's my brain working right now? I just, it's like literally working. Today. Like I know, like something clicked overnight or something. I don't know. Maybe I should go to bed at 1 every night.
I was gonna say, maybe it shouldn't like,
Are you all talking or thinking?
Both.
I think I want to give you a hard one.
No, we're not really trying more than that.
Oh. Maybe.
Oh, now we're in
That's
radians.
7 pi over 12.
Now we're in radians.
I don't have my
And
glasses.
Chandler should be happy because now we're in radians. And she
Yeah.
wanted to do everything last time in radians.
Thanksgiving, no, because like just for the food.
Oh,
Just for the food.
All right,
But Christmas is open.
guys, can we go back to our list over here?
Yes. All right.
Go back to our list.
Yes.
And I'm going to change all of this to radians.
Oh. Okay.
Okay?
Oh, wait.
This is gonna take
It should be easy.
Yeah.
Yeah.
Okay.
Because
gotta
isn't
remember.
this pi over 2, pi, 3 pi over 2,
The 2 pi.
and 2 pi? What is 30 degrees?
Is pi over 6?
Is pi over 6?
Uh-huh.
Wait, which one?
30 degrees is pi over 6. You don't have
Yeah.
to.
Yes.
Okay. I was
Yes.
just making sure.
That's pi over 6.
Okay, what is, I can convert each of these, I can look, pi over 6 in quadrant 1. What's pi over 6 in quadrant 2?
Pi over 6.
Two.
Isn't it 5 pi over 6?
Yeah, I was getting to that.
What is 3?
That would be 7 pi over
And 4?
6. That would be 11 pi over
Okay, now let me show you kind of a shortcut on finding those.
Oh, okay.
Since it's 1/6, it goes all the way through, doesn't it? All the way around. Well, what I do is I go to 1/6, will not reduce. We start with 1 pi over 6. Will 2 pi over 6 reduce?
6. Yeah.
3 pi over 6 reduce?
Yeah.
4 pi over 6 reduce?
Yep.
What's next? 5 pi over 6. 6 pi over 6, does that reduce? 7?
No.
We have a 7. Does 8 pi over 6 reduce? 9 pi over 6?
Yeah.
10?
Yeah.
So I'm to 11 pi over 6. Now, I'm going to do the same thing, because what is 60 degrees?
Pi over 3.
Pi over 3. So what is that going to be in quadrant 2?
2
Pi.
I wrote 3,000 degrees.
We're in radian.
What's quadrant 3?
4 pi over
4 pi over 3? And what is quadrant 4? Does that make sense?
3. Yeah, because 3 pi over 3 is 6 pi over 3 is the only one.
Okay, what's 45 degrees?
Pi over
4.
I had to think about that one. I was like,
Pi over 4.
Pi over 2
So, what about in quadrant 2?
would be 3 pi over 4.
Yes.
And then 5 pi over 4.
And then
7 pi.
Now, the hard part. I have to find 2 of these in radians that add up to 7 pi over 12. Add or subtract. And I will tell you,
3, 4, and 6.
when you're in radians, it is much easier if they add rather than subtract.
3, 4, and 6 all
Yeah, so any of those will work. You're right.
which is kind of nice.
Pi over 3.
Pi over 3, pi over 4. Okay.
Exactly.
You all agree?
I would agree.
Yes, I do agree.
Now, the nice thing about this one is they're all in quadrant 1. So I don't have to worry about whether they're positive or negative. They're all positive. Right? Agree?
Yes.
All right. So my formula is tangent of pi over 3 plus tangent of pi over 4 over 1 minus tan pi over 3 tan pi over 4. Agree? All right. We said they're both in quadrant 1. So I'm going to draw them. However, I think you should know one of them.
Yeah.
Pi over 3. This is pi over 3. What is this side?
A radical 3.
This would be,
1.
and that would be 2.
Josh.
Right?
Yes.
So, what's the tangent of pi over 3?
Radical 3.
Radical 3 plus
1. Right? Yeah.
Is the tangent of pi over 4 1?
Yes.
Are you supposed to know that?
Yes.
Yeah.
Do I? Not necessarily. Should I? Absolutely.
Now, once I have found
You're
these,
working off.
I'm going to use the same ones in the denominator, all
I
right?
just cancel them out. Roll.
1 minus radical 3 times 1. Right?
Well, it's the same thing.
No, it is not. I have radical 3 plus 1
Oh, it's a minus on the
over
bottom.
1 minus radical 3.
I did not write it as a minus on
We
the
get rid
bottom.
of the radical 3 though.
How?
Sorry.
No. You cannot do that if they have something added
Oh,
to
do you need
them.
to break
Oh.
it in? Oh, is that the answer?
That's not the answer.
Do we need to break it into 2?
No,
Oh.
we
I
can't.
like mine. That would be good.
Looks like you can break it into 2.
Yeah.
Nice try. However, that's going to take a long red pen to grade your paper.
All right. So turn the 1 to sine squared plus.
Yeah.
Never miss Poppins.
Can we leave a radical in the denominator?
No.
Ah, okay. Okay.
There is more.
I see what she did there.
I said multiply.
But wait.
There's more.
If there's 1, 2, wouldn't you, if you,
Is the answer just 4?
So you're gonna end up distributing radical 3 into 1, too. So it's gonna be radical 3 minus
Is
3.
the answer -4?
No?
Final answer, -4.
Why would it be negative? Can't you spelled it?
I don't know.
Since you gotta multiply.
You remember the term conjugate?
Ah, I don't like that term.
Conjugate means the opposite side. So I multiply top and bottom by the conjugate of the bottom, which is 1 plus radical 3.
Then we
So this
got
is what I multiply.
3
Oh,
plus
yeah.
4
Remember the conjugate?
over 1 minus
almost.
radical 3.
So I just, on top, don't I have
Oh, the answer is just 4.
radical
I'm
3
so close.
plus 3 plus 1 plus radical 3. I FOIL the top.
Oh,
And also radical 3 plus 4.
I FOIL the top. The bottom, when you multiply conjugates, you square the first. What's 1 squared?
1.
Minus square the second. What is radical 3 squared? 3.
So you cancel.
So,
go that for
So then is it radical 3 minus 2?
on top, do I have 2 radical 3 plus 4?
yes.
What do I have on bottom? In order to get rid of that -2, on top, I have to factor out a -2. When I factor out a -2, do I get negative radical 3 minus 2?
Yes. Can we just cancel out?
Well, why would you do that? You not just bring up the negative and
That's what she did. She thought it
would you have to put both those together?
Yeah, why can't we cancel out the negative 2 now?
I'm going to.
Oh, okay. Okay.
So my answer is negative radical 3 minus 2?
Yep. I did not like
Was that a hard one?
it. Yes.
Yeah.
I thought it was a hard one.
I was
I would have